In this chapter, we're going to learn about some of the characteristic features of organic molecules. The study of organic molecules is called organic chemistry. Now, if I ask you to define organic, you may come up with a definition that is not related to organic chemistry. You might come up with definition 2. If you're talking about food and farming method, produced or involving the production without the use of chemicals. Not organic chemistry. You might talk about 3, relating to bodily organ or organs. While organic chemistry is involved in these things, this is not the definition of organic chemistry. Or here, in business, they might say that something was organic, denoting a relation between the elements of something such that they fit together harmoniously. Not organic chemistry. So if we look at this first definition, it says relating to or derived from living matter. Okay, but that's still not what organic chemistry is. Organic chemistry is right here. It's the study of compounds that contain carbon. So we're going to investigate a few of the features that involve compounds that contain the element carbon. Now, it may seem unusual that an entire classification of chemistry would be centered around this one element, carbon. But there are so many molecules, millions in fact, are known that involve carbon, far more than any inorganic compounds that we've thought about in the first chapters of this book. Organic chemicals affect virtually every facet of our lives, and for this reason, it's important to know a little bit about them. If you were to go on and study chemistry, organic chemistry can be semesters of study. So again, the definition of organic chemistry is the study of chemicals or compounds that contain carbon. So very simply, looking here, glucose has carbon and it's considered organic. Magnesium hydroxide with no carbon would be considered inorganic. Now, organic compounds, while we may associate the word organic as something to do with nature, organic compounds may be found in nature, but we can also synthesize these same chemicals or even new chemicals in a lab. Things like cotton, wool, or silk naturally occur, so they could be found directly from natural sources. Other things like nylon or polyester are synthetic, meaning that they are produced by chemists in the laboratory. But both of these things, because they contain carbon, would be considered a part of organic chemistry. So looking at these formulas, let's identify if something's organic or inorganic. And remember, we're looking for the element carbon. So letter A would be organic. Now H2O is water, and we may fall back on the misconception that organic means that it's found in nature. But in the terms of chemistry, organic means it contains carbon, so water is inorganic. Potassium iodide with no carbon is inorganic. Here we have a carbon, so this is organic. And then magnesium sulfate with no carbon is inorganic. So our discussion in the next few videos of organic chemistry is not inclusive or all-inclusive. We won't be able to cover everything. This is a very big topic, but we'll be just looking at a few features and characteristics that might help us understand these molecules just a little bit better.